Hello everyone, I'm John from Autel. Welcome to the first actual webinar that I've been doing for Autel since I've been hired. My title at Autel is the EV Trainer, hence the reason for tonight's subject matter. So I've got a lot of interesting stuff in store for you. I do these classes all across the country, and I am taking one small section of this class for tonight's webinar. Tonight's webinar is going to be on battery management systems, and I'm going to share with you not only how they work and all the details, all the different sensors and stuff that make up a battery management system, but more importantly, why you need to know what a battery management system is, and also how to go ahead and diagnose a battery management system, because that's what's mostly important. So with that being said, the screen that you looked at while you were waiting in the waiting room was a picture of a brand new tool that Autel has out. It's called the EVDiag Box. Now, if you don't happen to have one of the Autel scan tools right now, you could buy either the EV909 scan tool, the 919 scan tool, or the Autel Ultra scan tool and order it with the EVDiag Box. This is a very unique tool. I've been involved with this tool since it's first been brought over here to the States. A lot of research and development, and no other scan tool on the market has the ability to do what this tool does. Now, if you currently already have one of those three scan tools, Autel does sell just the upgrade to EVDiag Box. And you'll be able to get the box and all of the different cables and everything that you'll see as we go through tonight's webinar. Also on that first screen was a picture of an Autel charger. And if you remember from that first screen, it said if you had that diagnostic tool as well as a charger, that equals you making money. So with that being said, a little bit of background about myself. I still work on cars on a daily basis, mostly for research and development purposes at this point, but I still do it. So every time I do a class, I'm sure there's a lot of you that have sat in on some of my classes in the past, but every time I do a class, my philosophy is this: you got to keep it real world, and what's most important in any training class, in my opinion, is to make sure that you gain information that can start to make you money in your service bays tomorrow. Now, the EV revolution that's happening throughout the industry, that's something that whether you like it or don't like it, I will tell you that I'm old as dirt, and I've been around since a lot of different types of technology has been released into the automotive industry. I can remember when computer controls first came on cars, and everybody said it was a passing fad and everything else. I will tell you that I am 100% confident that this EV revolution, if you want to call it that, is going to happen in the automotive industry. And what's most important is that you embrace the technology at an early stage so that you don't start to become dated, and when these cars start filling up your service bays, you can't have an option to go ahead and diagnose and repair them. So I applaud your efforts of attending tonight's webinar. Now, with that being said, I've got just about 10 slides to share with you. The rest of it's all going to be hands-on on this 2017 Chevy Volt behind me. There's an interesting story about this Chevy Volt, which I'll share with you as we go through. So you can see on your screen right now the battery management system. And what is a battery management system? Don't pay too much attention to that picture yet, even though, you know, a picture is worth 1,000 words. But every single hybrid, plug-in hybrid, or electric vehicle has a battery management system. The battery management system is made to protect the vehicle's battery, the high voltage battery. Let's face it, that's the most expensive component on any of these vehicles. So we want to protect that battery. We want to make sure that it has a long lifespan. We want to make sure that the consumer that owns this vehicle is not confronted with a big dollar battery replacement until the battery just can't be saved any longer, which typically is well over 10 years. The typical actual warranty from the different manufacturers is 8 years. That's the minimum here in the United States. So on average, it's not uncommon for the batteries to last 10 to 14 years, depending on the different vehicles that you come across. So a battery management system has several different components in it. It will have all kinds of thermistors, all kinds of temperature-related sensors. It will also go ahead and have voltage and current sensors as well. Anytime, if it's a plug-in hybrid, like the example that we're going to work on here tonight, or if it's a full electric vehicle, anytime we use an electric vehicle charger, well, that charger, when we connect it to the car, has something that's called a handshake that occurs. And we'll spend more time on that here in a couple slides. But all of these components work together to make sure that this battery is well maintained and is not entering into an unsafe zone. So there's a lot of rumors going around on the internet. You know, I used to try to respond to them, but at this point I just let them go from this point on. But you know, all the different stuff that you hear the naysayers say. Stuff like the cars are going to catch on fire and the batteries are expensive and we don't have enough power in the grid. And I literally can answer knowledgeably any one of those complaints that people have, with the exception of the high voltage battery is expensive. That is true. In the future, it may come down in price, but everything else that you've heard negative-wise about an electric drive vehicle, I can tell you and give you some education as to none of that stuff holds any water, so to speak. So we're going to talk about diagnosing the battery management system, but we're going to talk about different types of complaints that you may have on a vehicle and how you're going to go about diagnosing these types of complaints. Now, focus your attention on that, on the picture, and that is a little prelude into the new diagnostic scan tool that Autel has to offer. So a traditional scan tool will go ahead and plug it into the OBD2 connector on a vehicle, and the information it can display is only what's shared along the data bus communication lines coming from the ALDL connector. However, this new tool can still do that, but we can also directly attach to the battery management system. To the best of my knowledge, no other competitor scan tool has the ability to do that. And you're going to see why that's important here as the night goes on. So we want to make sure that the battery management system's up to par. And what are some of the inputs? Well, you can see on your screen that some of the inputs are, we're going to have current sensors. You can see that happens to be out of a Toyota Prius, that example there, but it's nice and easy. It's right up on top. Also, you'll see how the orange cabling runs through, one of the two battery cables will run through that current sensor. It's located with the white arrow there. We also have high voltage switching contactors. High voltage switching contactors, if you want to think of it as a relay, go right ahead and think of it as a relay, but it has two sets of contact points inside of it. So any high voltage vehicle still needs all of the preliminary circuits to work on the vehicle. So if you get a high voltage vehicle that will not power up for some reason, well, you still need a brake on off switch. You still need the vehicle in park or neutral. You still need an ignition switch. You still need all of those preliminary inputs to work. If I have no communication on the data bus lines, well, I'm going to have to diagnose that first, right? So we'll talk about that as we go through the scan tool demonstration here with this particular Chevy Volt. The high voltage switching contactors, however, are important on every electric drive type of vehicle. You will either have one set or sometimes two sets. So what is the purpose of this? In order for an electric drive vehicle to actually start moving down the road, we need to have a high amount of voltage. Technically, it has to be converted into AC voltage, but not in tonight's class, but in the next series of classes when we go over motor generators, we're going to actually see that it's not really AC voltage, it's still DC voltage, But through pulse width modulation, the car is tricked into thinking it's AC voltage. We'll show that picture perfect in a future seminar that we have together. But getting back to those high voltage switching contactors, it's important for you to understand that once I go ahead and hit the start button on the dash of an electric drive vehicle, and I obviously have my foot on the brake pedal and it's in park and all that other preliminary stuff, the high voltage at that point is still all stuck in the high voltage battery pack until we close those high voltage switching contactors. We do that with 12 volts, low voltage. So we need, what we just said is, we need a good 12 volt battery in the car for these things to ever power up. Once we close those high voltage switching contactors, we have a total of 2 of them in most cases, and sometimes we use what's called a pre-charge relay as well in conjunction with it. With that being said, we can't just release 200, 400, 600, 800 volts right up to the actual capacitors that's usually found in either an onboard charger or an inverter. We can't just release that because that's called a rush amperage. The rush current, it's going to cause some problems to happen. So that's why we use the actual pre-charge relay. May sound confusing right now. I'm going to simplify it for everybody in attendance here tonight. So let's go ahead and continue on here. And when we're talking about charging a high voltage vehicle, so any type of electric drive vehicle, you see on the right hand side of your screen, those are the 4 most popular style charging connectors, right? So whether it's a plug-in hybrid or it happens to be a full legitimate electric vehicle, you're going to have one of those 4. Tesla is kind of unique. It will have its own separate connector. It's not a big deal though. They give you an actual adapter. So with that being said, we're going to look at the picture on the left hand side of our screen, because you can see that with the CCS style connector, which is the most common style DC fast charger connector, we still have that connector on the top of that, as well as if it's a plug-in hybrid and it only has what's called the J1772 style connector. Now the terminals inside that become very important. So obviously line 1, L1, L2, or / neutral, and equipment ground, that's going to be if the vehicle is only capable of level 2 charging. So we would have current coming from our charger on that, right? So 240 volts of AC voltage, let's say. Now the other 2 terminals, those become very important, and we're going to investigate that because that's where you might have a problem, where a customer comes to you and they bring you a vehicle and they say, hey, I plugged my electric vehicle in all night long, so it charged for 8 hours, 9 hours, however many hours it turns out to be. And when I woke up in the morning, it only has 3 miles of range in it, right? So that's going to be a common type of complaint that comes into your shop. So it's our job to figure out why that is. Is it a bad high voltage battery? Remember, those are expensive. We don't want to just shotgun that diagnosis and put one in and then still have the same problem, right? So we got those other 2 terminals. One is the control pilot and one is the proximity detection. If you happen to have or have ever worked on an electric drive vehicle that has some type of charging port on it, you'll notice that when you hook it up to a charger, certain things will happen. There's going to be like a little light on the dash on most cars that are telling you that it's actually accepting a charge at that point. As soon as I plug that connector in, that's where the proximity detection comes into play. It recognizes that there is a charger plugged into the port on the vehicle. If it never sees that circuit complete, the vehicle's not going to want to charge, right? It doesn't know that there's something plugged into it. Now the control pilot, that's the communication that occurs. That is the communication that's occurring between the car and the charger. Now, with that being said, we're going to have to diagnose that circuit at different types of complaints as well. But again, I'll save those complaints for when we're looking at the data stream on the vehicle, so it'll make a little bit more sense to us. So I just wanted to show you different types of electrical plugs that are available. Going to the next slide here. Here is a pictorial view of the communication on most vehicles between the charger and the car. So I know it's a little small for you to see right now. I'm just going to summarize some of it. And again, each car is a little bit different. But number one, we got to know when there's something plugged into the charging port. We want to make sure that that charging port becomes awake and active. We want to make sure that it is able to accept the current being delivered, either if it's DC fast charging directly to the high voltage battery, or if it's an AC style car like most plug-in hybrids, it's going to have to go through, because we're giving it AC voltage, it's going to have to go through the inverter to convert that to DC voltage. And in some applications, we might even have to go through a DC to DC converter, because we might have to step up or step down that voltage depending on the type of charger we're plugged into. So at different levels of that, you can see the communication, which is highlighted with the little yellow snowflakes there, that's happening between the car and the charger. With that being said, there's a lot of questions that usually comes up. So one of the questions is, what kind of charger do I need to charge my vehicle, right? The car's going to come with what's called an emergency charger, which is a level 1 charger. The most popular question is, how long does it take to charge an electric vehicle? There's a lot of variables in that. How much voltage is in the battery when you start it, right? What level charger? How much power output can the charger deliver? So there's a lot of variables to that question. But just for sake of argument, if you know the kilowatt hour rating of the battery that came in the car, you can Google it and you can find the answer to that. And you know the kilowatt output of the charger, the max it can put out, that's a pretty safe way of figuring out. So if you just use those two figures and divide them, that's a pretty safe way of figuring out about how long it's going to take to charge that car. Remember this, every car's battery management system is in control of the charge. So even if I pull up to the biggest and baddest DC fast charger that I can find in my particular neighborhood, and maybe it's capable of giving me 450 amps and over 1,000 volts, most cars cannot accept that. The battery management system will bottleneck down whatever it needs so that it can actually safely charge that battery. Remember, when we're flowing electricity, one of the byproducts of flowing electricity is heat, right? So that one little statement that we said before that, hey, these things are fire traps and they're always going to catch on fire and everything else, well, if the car's working the way it's supposed to work, then theoretically that should be impossible for that to ever happen. It will literally stop the charge. It will power up all the different circuits on the car. Possibly some of these batteries are cooled with coolant or air, whatever the case happens to be, and it's going to try to cool off that battery pack. It also goes ahead and saves the high voltage electric vehicle charger as well. So if that ever started to get too hot, that charger is going to shut off as well. So now that you have a kind of a little generalized understanding of what is the communication that's happening between the car and the charger, and you understand that the car is always going to dictate what it can take from the charger. So those are two key points that we have to keep in mind there. Now, another thing that's happening in the industry, on your screen you'll see a slide that says, what is ISO 15118? So, ISO 15118 is on some vehicles that are out on the road right now, just a handful of them. But by 2025, every time a manufacturer creates a new high voltage vehicle of some sort, it has to comply with this standard, much like OBD2 did back in 1996. So why is this important? Well, a couple things. ISO 15118 has two parts to it. One of them has to do with the plug and charge capability, which basically means I can pull up to a charger, I will already have payment linked to my phone, and I can just plug into a charger, much like Tesla does with their own little closed charging network, and I don't have to use a credit card or something else, right? So that's nice, but it's not really mechanic worthy, right? But the other part of this is kind of mechanic worthy. The V2X, so vehicle to grid, vehicle to home, vehicle to campsite, vehicle to whatever, right? We have bidirectional capability anytime we have a vehicle and a charger that are both ISO 15118 compatible. So our grid can't take all this electrical demand, right? Think about this. You have a power plant in an electric vehicle. You can go ahead and power your house up off of your car with 15118, right? So there's a lot of different things that we hear on the internet all the time, and most people are speaking because they've never been to any kind of formal training. All right, so going to the next slide here, you can see what has Autel done to help us out as technicians. So a couple things. Once all the car lines started to go electric, Autel got on board and said, well, it makes perfect sense. These shops are going to need a charger. So let's talk about that for a second. Why do you need a charger? Here's what's different about an electric drive vehicle. When you pull an internal combustion engine into your shop to do whatever service it's in there for, you're not using any gas as long as the engine is shut off. But an electric drive vehicle will be using some electrons, not much, but some electrons the entire time while it's in your shop. So when a customer brings you a car right now, do they always have a full tank of gas? No, most likely. They're coming in on fumes, right? So what happens if the electric car driver comes in and he doesn't have that much? Maybe he's got 10% battery life left. And by the time you're done doing whatever it is that you're doing to the vehicle, now you got to charge your car. If the only charger you have at your shop is the emergency charger that came with the car, that's a 110 outlet, and it has very low kilowatt amperage output, that is going to take, in some cases, better than 40 hours to fully charge that battery. We don't have that kind of time in the automotive industry. Our parking lots and our actual service bays are way too valuable for us. We can't dedicate a spot for a car to sit while it's charging its battery. So we need something that's going to charge it faster. Do we need a DC fast charger? In my honest opinion as a technician, no. We just need a level 2 charger, which is very affordable, and we'll talk about that as we go through the night as well. We also need that charger for the secondary reason. That complaint that we said earlier, hey, I plugged my car in all night long and I don't have any kind of range when it's done. Well, how are we going to diagnose that if we don't have a charger to see, what's happening as I plug a charger into the car? So we definitely need a charger, right? Also, Autel has gone ahead and made a new scan tool that says, hey, we're going to give you the capability to plug directly into the battery management system. Now, when you have that capability, that becomes huge because I can see all the different inputs that I could not see that were just shared along the data bus line of communications going to the OBD2 connector. I've got an example of a battery where I'm going to explain that in greater detail for you. Also, some of the things that this tool does for us, you can see on the far left-hand side there, it shows you all the individual battery cell voltages. It also tells you the battery state of health, battery state of charge. We're going to talk about that here in a little bit, why that's important, a way you can use those two things and recalibrate them. That's something that most people don't even know anything about, but being able to recalibrate the battery state of health, which is needed on every high voltage battery, will prolong the battery life for your customer. We will also pull up wiring diagrams on the screen that will show you exactly how to make the connection. We'll also be able to pull up component diagrams. So it will tell you how these systems, how these components on these systems interact with one another, and it will aid you in your diagnostics when you get to those screens to say, well, at this point I got my scan tool hooked up and it's telling me I got the voltage coming here, but when it goes to the next part in the whole range of this whole electrical circuit here, that voltage is gone, right? So where's the problem at? Is it in the harness? Is it in one of the components? We're going to talk about how to diagnose that. So those are just 3 sample screenshots that no other scan tool, again, to the best of my knowledge, gives us the ability to do. Now, on this Chevy Volt has an interesting story. Relatively new customer, and honestly, I don't have a traditional customer database anymore. When I closed my shop down and moved to my pole barn, which is where we're in tonight, I went ahead and took my 2,000 customers in my database and I gave them to other shops. But I still need to always keep my skills current as a technician. So I went to all of the shops that were customers of mine and I said, listen, any one of those vehicles that you have that it doesn't matter what the problem is, if it's an electrical problem or lack of communication or anything that's giving you troubles, you guys are my only customers. I only want the headache jobs to keep my skills current. So this happens to be from another shop, and this came to me about 2 months ago. The other shop was able to diagnose it as it needed a new high voltage battery. So they wanted a second opinion because, again, these are expensive. So I went ahead and did the diagnostics. I agreed with them that a high voltage battery was needed on this vehicle. I went ahead and put that high voltage battery in, and then I said to the shop, hey, tell the customer to come back in a couple months because I want to go ahead and review the data stream. So I've got some screenshots that I took the first time it was around, but when we start using our actual EV diagnostic box, one of the things that it will tell us to do, and every car is a little bit different, this one happened to use the universal connectors. It pulled up on the screen of the 12-volt connector that I had to unplug from the high voltage battery pack and told me how to insert this into the terminals so I can get the following screenshot. So I went ahead and just followed the directions on the scan tool screen, captured the results so that I can use it for a database. And realistically, I'm kind of selfish. I use it for training classes. So I not only make the money on diagnosing and repairing the cars, but then in the future when I'm using it in training classes, it's the gift that keeps on giving, right? Now, not every car goes ahead and makes you use these universal type of pins. So we'll hold this box up a little bit later on, but some of the vehicles, depending on the vehicle you're working on, will actually have the actual pigtail right on there. So it'll tell you to just grab this connector. Obviously, we'll talk about how this whole thing is hooked up here in a little bit, but we'll unplug the 12-volt connector, we'll plug this in. And we'll plug this directly into the battery management system, and we'll be able to see everything that we couldn't see before that was just being shared along the data bus lines of communication. So again, this is something that no other scan tool really offers for us right now, and Autel has gone ahead and really thought outside of the box when they created this scan tool and allowed us to do this. So just so you know, I'm going to go ahead and flip to the slide here again. This is what a Chevy Volt high voltage battery pack looks like, and I kind of labeled it for you with the two terminals or the two connectors at the very bottom. So the big orange ones, those are high voltage. We're not hooking the scan tool up to those circuits. We're hooking them up to the two connectors at the bottom of the screen there. In that case, I had to use the little universal type of pins. Now, the screenshot that I grabbed the first time is being displayed on the screen for you right now. So you can see the individual cell voltages from that battery when it needed a battery replacement. But at the top of the screen, you can also see SOC in the left-hand corner, SOH, so that will stand for state of charge and state of health. And the state of health of this battery pack is only 10%. Traditionally, anytime the state of health of a battery pack drops below 80%, the consumer is going to start to notice a decrease in range of a fully charged vehicle. So that's not something that happened overnight. I'm sure this customer, these cars got about 60 miles on a fully charged battery because it's a hybrid, right? So I'm sure that 60-mile range dropped down to 58, 53, 40 miles, 30-something miles, and then now it basically needs a battery. So that's important. We're going to talk about that in greater detail. We can also see the actual battery pack voltage and the total current of that battery pack. We also see at the top of the screen the pack voltage difference. So inside every battery pack, which I'll show you here on an example in a second, we have lots of individual cells, and those individual cells are always being compared one to another. If the difference between these cells become too great, we're going to set trouble codes. That's called battery balancing, right? Then we also can monitor the temperature of the battery pack. So again, a typically normal range for a temperature of a high voltage battery pack should be between about 65, 68 degrees Fahrenheit up to about 95 to 100 degrees Fahrenheit. If it gets hotter than that, it's no good. It's going to want to go into self-protection mode. We also, if it's too cold, that's no good either, because a battery when it's cold, just like smart charging systems from days gone past, wants to resist the charge. So we want that optimum range there. Now, that was the screenshot that I captured from it, but let's talk a little bit about state of health. So on the next slide there, I'm going to summarize this real quick and easy, and it's not just high voltage batteries that this happens to, it's batteries in general. A battery over time will have its internal impedance change. So what does that mean and why do we care? Well, a battery over time starts to fail. We start to fail because the battery state of health with the ionic ohmic values, that is determined by the actual terminals inside the battery pack, inside the individual cells, as well as how conductive the electrolyte is inside the batteries. As the battery ages, we have more and more resistance that builds up. So we don't want to accept the full charge, because now what happens is I plug a charger in just like I normally would, but these batteries have started to age and the battery never receives the full voltage that it did when it was brand new, which is why on the dashboard screens of the customers' cars, they'll start to see over time, hey, I used to get 200 and something miles with a full charge. Now I'm only getting, maybe 40 miles less. And then as that continues to degrade over time, I get even less and less and less. Well, that's because the battery is never fully charging, because it was made with brand new electrolyte and everything had no kind of problem, and it knew how much voltage it should take to fully charge that battery. So you can read the 3 little paragraphs on the screen there to get a more detailed explanation of it, but summarizing what we just said, that's pretty much what we need to know as a mechanic as to why that happens. So it was at 10% when the battery had to be changed. Now, Autel also took another step, and they went ahead and developed a full line of electric vehicle chargers. Everything from what we call a residential charger all the way up to a DC fast charger of high output values. So on your screen, you saw that you had the small little boxes that hang on the wall that could be perfect for residential applications. Now, something that I talk to the EV team at Autel about all the time, coming from the automotive industry, most shops, in my opinion, don't need the higher end chargers, because unless you're in the business of charging people some type of monetary figure to charge up their battery, you probably need that parking space or the service bay to do something way more productive for you, financially productive, something like brakes and front end work and everything else. But we do need a charger. We need a charger because we can't give this car back to the customer with 8 miles of range and hope they can make it home with that, right? We don't want to use the emergency charger that came with the car because we don't have that kind of time to let it charge. And plus we need a charger to diagnose those lack of charging type of complaints. Now, we do have 2 different smaller models that in my opinion are perfect for an auto repair shop, but if it were me, I would go with the residential charger, because I don't want to be in the business of collecting money to allow people to charge their cars, right? So a residential charger will suit my needs as a professional repair technician just fine. Now, your personal needs may be different, but I think that most people that are on tonight's webinar are probably all going to agree with what I'm saying. So a typical charge for an electric car might be 20 or 30 bucks, but that car might be sitting there, you know, if it's the high-powered DC fast charger and it's charging the vehicle up in, you know, 20, 25 minutes or so, that's still 20 or 25 minutes of a parking spot that you can't use in your front of your shop, right? You got to leave it open so other cars can pull in and out of there. So a level 2 charger that's a residential charger is pretty much what I would recommend. So that's another way that Autel has helped us out here. Now, the rest of the class here, we're going to do all hands-on. So I'm going to go ahead and I'm going to go over to a sample battery pack that I have. And the sample battery pack, this is actually out of a Hyundai or a Kia. And this here is a battery pack that's been replaced. I know it's not a full electric vehicle battery, but you know why I'm using this. Because a full electric vehicle battery is about the size of the whole floorboard on the car. So this is a lot more manageable for training purposes. You can see the individual cells, how they're made up here. You can see that the battery pack has the contactors built right into it. You can kind of see where we would plug the scan tool in at for the battery management system over here. We also have these orange wires at the top. So it looks like I got 1, 2, 3, 4, 5, I got 6 at the top. Now those wires are actually thermistors. Now at the bottom of the battery pack, on the opposite side, so these are all kind of at the top of your screen, there's another 6 at the bottom of the screen of the battery pack here that we can't see without disassembling these individual cells. So that's a total of 12 thermistors inside this small high voltage battery, right? Now an electric vehicle has way more cells in it, could be well over 1,000 cells, and we will have even more thermistors in it. Remember this because when I hook up a scan tool, we'll be able to see battery temperature, but it's going to give us an average. It won't allow us to see every one of those thermistors. So hooking up directly to the battery management system, however, I can actually pull up readings from any one of those thermistors inside of a battery pack. So in your mind, you're thinking, okay, perfect. I can use that to help me diagnose if one of those thermistors has failed. And you can. But also remember, electrons are still electrons. All the golden rules we learned about electricity still apply with high voltage. Anytime that I am flowing more current through something, we are going to increase the temperature. So if I'm using the new Autel scan tool and I'm looking at the individual cell voltages and I'm comparing them one to another, if I have one that's starting to fail, the internal resistance of that battery pack is going to increase, which will decrease the amount of amperage. So in that case, I'm using it to help me confirm my suspicions that I have an individual cell that is starting to fail. Now, how are you going to repair that? Well, depends on where you work, right? Some manufacturers will say you can go ahead and replace an individual cell, but on a full electric vehicle, you're probably changing a group of cells. So like we'll use a Tesla battery as an example. There are 16 big groups of cells, about the size of this whole battery. So we have about 16 of those, and if one of those battery cell modules were to fail, we would probably go ahead and replace just that one cell. But again, I can help use the temperature of the high voltage battery here with being able to look at all the different thermistors to help me determine what my real problem is with this high voltage battery pack. That's just one example. We also have the switching contactors on the side, but I'm gonna do something else with those to make it a little easier for us to all see. Remember, we will use low voltage to close these switching contactors to then go ahead and allow this high voltage to go out and power up everything else on the vehicle that has an orange cable. So I just wanted to kind of show you this real quick, just so we have a kind of an idea of what's inside of a traditional battery pack. And at this point, we don't really need this anymore, so I'm just going to move it out of the way. And I'm going to go to the table over here, and I have quite a few different types of components. So here is a little training aid that I made, and this training aid is technically a high voltage battery pack. I only got 2 individual cells here just to make it safe, so I don't have to wear the rubber gloves or anything else. So this will equal up to about 15 volts when these are fully charged. Now I'm going to go ahead and show you basically what happens here. So I've got a 9-volt battery, which would be the equivalent of like the 12-volt car battery, and I'm just going to connect these 2 battery terminals here to power up my board, and I'm going to turn it off, and I've got my little voltmeter over here. And the first thing I'm going to do is I'm going to put it on regular DC voltage, and all of the individual cells inside the battery pack will hook up to one side of these high voltage switching contactors. So if I were to go to that side, I should read whatever this high voltage battery pack reads. So I'm going to go to this, and it says I have 15.53 volts, right? So with that being said, because the ignition switch is not turned on right now, if I go to the other side, I don't have any voltage flowing. Every high voltage vehicle works this way. They all will have some high voltage switching contactors inside the battery pack to control this. It's a safety measure. Now, once I go ahead and I say, hey, it's time to power up this vehicle, so I can actually put these leads right in here. I still got the 0 volts. Once I go ahead and I stepped on the brake pedal and it's in park and everything else, and I hit the start button, now it releases, so these 2 terminals I got this hooked up to are the other side of those contactors, it releases the high voltage. So in this case it's only 15 volts, but if it was hooked up to that battery we just saw, it would be about 280 volts that would be going out to the car. This is something that we can always use to disable the high voltage threat from a vehicle. We can make sure that those switching contactors do not close. You can do it with the scan tool, and I know I work for a scan tool company, and I probably shouldn't say this, but I'm going to anyways because it's safety related. I'm never going to trust the scan tool. How many times have we tried a power brake bleed on an ABS system and the scan tool said it did it, but it doesn't do it, right? Well, I don't want that problem when I am dealing with my life here. So if I'm going to use my scan tool and I'm going to say open up those high voltage switching contactors, I'm not going to take off my protective gear until I prove that that high voltage is no longer a threat, right? Because what happens if these high voltage switching contactors are stuck closed? Even though my scan tool told them to open, if they're stuck closed, it's still sending high voltage out. So let's say I was going to change an AC compressor, right? And it's a high voltage AC compressor. I think I powered down the system, but if this is physically stuck closed and I just don't have gloves on and I start working with my bare hands, I run the risk of being electrocuted. So I'm always going to prove out that this circuit is dead before I start servicing anything on an electric vehicle. I'm always going to prove that out first. If for some reason you can't find a high voltage disconnect, the high voltage disconnect on this 17 volt here is actually inside the center console. So, but if it didn't have one, because a lot of cars are going away from having that and they're telling you to use the actual scan tool to open up those contactors, always prove that out first And as an extra layer of safety, even disconnect the 12-volt battery. Remember, it takes 12 volts to cause these to close. So if the 12 volts isn't present, they can't possibly close. The other thing too is I can always physically open these up, right? So I can take the battery cables, go into the car while wearing the actual high voltage gloves, and I can disconnect them from the other side of the contactors to make sure that there's no way that that voltage is going to be flowing. Now, with that being said, let's talk a little bit about those orange wires. So here's a traditional orange wire, and we also have an overall insulation and inductance test. Orange wires are going to everything high voltage on this vehicle. We use an isolated ground on anything high voltage. But if I have high voltage going to a metal box that's called a magical inverter, which we'll talk about in a future episode here, if that metal box, if there's a short inside there in some way, then technically, if I were to touch anything metal on the car that's chassis ground, I would get electrocuted. So those are very important things for us to understand. And the new Autel scan tool has tests built in to test that before I even get out of the driver's seat. So every orange wire will actually have an actual test built into it as well that I can use an insulation test for one, but I can also test its inductance, right? So I can go ahead and make sure that there's no leakage that's occurring here. If I were to take and use a meter, and we'll do this in the next episode that we're all together in, and this particular meter will put out 1,000 volts, up to 1,000 volts, and I can actually run 1,000 volts through this wire, and then I would be looking at an actual resistance reading that's going to come back. And I would want to see at a 1,000 volt scale, I'd want to see 2.2 giga ohms of resistance, which would help me understand that there's no breakdown here on here. This wire is not shorted in any way. But while I'm doing that test, if I were to pierce this orange wire, so I take a little thumbtack when we do this part of the class in the next episode, and I just poke it. So if you're one of the guys that like to, back probe stuff and poke wires, that cable is now dead. Even after I take that thumbtack out, it will not flow electricity anymore on a high voltage orange wire there. So keep that in mind. We'll show it in the next episode. Just wanted to throw that out there while we're doing it. Now, the next thing that we want to talk about with high voltage before we hook up the scan tool is we want to talk about either an inverter or an onboard charging module. So this one here happens to be off of a Tesla. I'm just going to take some components out of the way here so you can see this a little bit better. I'll move our little contactor board to the other table so it gives us some more room here. We don't need our 9-volt battery at all. So here is a Tesla onboard charger. This is the thing that's in control of what's happening on a Tesla whenever I plug into a charger of some sort. There's a lot of different circuitry inside here. A common thing, this is just a little tip, a common thing is if I'm using a level 2 charger, I have to convert that to DC. A car's battery is DC voltage. Level 2 chargers are delivering AC voltage. So I've labeled all this stuff. This board here is responsible for converting that to DC so I can then send it back to the battery. Now, a common thing that happens on Tesla is the vehicle will not charge. And you'll get some warning lights and stuff. On this side of the charger are two 50 amp fuses. One of those 50 amp fuses will blow. Now on a Tesla's kind of unique. During the handshake, remember, Teslas have their own cable, which are DC fast charging cables. So they're nice. They give us the ability to use a level 2 charger and be able to convert the AC to DC, but the Teslas were originally made to only accept the DC fast chargers. So with that being said, if one of these two two fuses were to blow, because basically when the handshake on a Tesla, when I start the charging process, that cable is physically locked into the connector. I can't unplug it until I stop the charging process. It doesn't work that way when I'm using a level 2 charger. So if I walk up and unplug the charger, it's not going to blow probably the first time. But if I do that enough, a voltage spike will occur because it's still in the charging process, and it'll blow one of those fuses. Then the vehicle can't charge anymore at all. I keep those fuses in stock. Now, if you take it to a Tesla dealership, they're going to want to replace this whole onboard charger to the tune of about $3,000. This fuse here is about 40 bucks, right? So this, you could do your customer a real solid, be a hero, and you can actually go ahead and replace just the fuse that's actually blown there. And then the vehicle will start to charge again. Now, traditionally, when I had to test the individual cells of a battery that started to have higher internal resistance, I would have to use what's called a milliohm meter. A milliohm meter is kind of unique. We use it for a bunch of stuff on a vehicle, but one of the unique things is it's got this special clip. The special clip, it's called a Kelvin clip here. Notice that it's got two leads going to it. What happens is the meter itself will put out about 1 amp for a halfway decent milliohm meter, and then it's going to be measuring resistance based off of a voltage drop that's occurring back in it. I would have to go remove the high voltage battery and actually connect this to the positive and negative terminal of every single individual cell to help me determine if the state of health was starting to fail because the internal resistance of the battery packs were getting too high, right? I don't have to do that anymore with the latest and greatest scan tool that we have to offer here. I can actually get that reading right through my scan tool screen. So with all that being said, I'm going to go ahead and I'm going to just throw some ideas out there of different types of problems and how you would diagnose it. So remember, the first thing I said was we need a 12-volt battery to work. We know we need it to work because it takes 12 volts to actually close those contactors that we talked about. So if I have a low or a bad 12-volt battery for whatever reason, that electric drive vehicle is never going to power up. So we can go ahead, and this isn't nothing real special. This is something that we've all used for quite some time. We can go ahead, I'm going to come around to the back of the car where the 12-volt battery happens to be, and I've got Autel's BT608 battery tester here. I've already got it hooked up to the positive and negative cable. I didn't think that you need to actually see a camera shot of a 12-volt battery. There's nothing special about that. So it's got its little internal PC built into it. It's powered up at this point. You'll see we'll start with doing a good 12-volt battery test. So I'm going to select in-vehicle test, and we'll give it a couple seconds. Maybe my fingers are dead and it doesn't recognize that I touched it, so let me touch it again. All right, it's an automobile, so I'm going to select automobile. It comes up and it says, hey, the VIN has been detected for me, and I can use that, right? So I don't have to go and tell it the cold cranking amperage and everything else. So this one here, I'm going to say, yep. Let's go ahead and hit the yes button. It pulls up. It's a 2017 Chevy Volt. Now I can go ahead and insert a couple pictures into here if I wanted to. Visual inspection pictures. Is the battery leaking? Does it appear to be cracked? Is there a lot of corrosion on it? Any of that kind of stuff. We're not going to send any pictures to it here. So I'm just going to say next. But if I did, that could be beneficial because I can add the photos where I needed to add them. And at the very end, I can have a nice professional printout for the customer. I'm going to say next again. It tells me to turn off all the electrical loads and accessories and stuff. We're going to say, yep, done, did all that. Let's go ahead and hit the start testing button. So I got to check the little boxes. And then say start testing, and pretty quick goes through. We're at 90% process right now. It comes up, it tells me to turn on the headlights, so I would follow the directions on the screen, turn the headlights on the vehicle. It's checking for a surface charge. And then it's going to come back when it's all said and done, and it's going to tell me if the battery's good or bad. I don't want to spend a whole lot of time going through using this tool, but as it's doing its thing, that now it's telling me to turn off the headlights here, you get the general idea of how this tool would work to actually test the 12-volt battery. So it comes up, tells me the battery's good. And if all the visual inspections took place and there was no kind of faults found with it, so cracking or corrosion or anything, I know I got a good 12-volt battery on the car. Quick and simple. I have the ability to hook this up to one of my scan tools as well and have the two of them interface so I can print out the report. I also have a built-in printer on this that I can actually use to print as well. But at this point, we're comfortable that we don't have a faulty 12-volt battery. So now I'm going to go ahead, I'm going to unplug the dongle for that battery tester and just put it up on the top of the roof there. And I'm going to pull this out real quick. This is the regular VCM module for the 919 scan tool. It's a combination box. It does reprogramming. It's got a lab scope built in it, a voltmeter, sensor simulator. It's a multi-use tool, right? Now, normally, every other scan tool on the market would have something similar to this, and then you'd take this OBD2 connector, you'd plug it in, and then most of today's scan tools are wireless, right? So I don't physically have to have a wire connecting this to my scan tool screen. When I use the EVDiagnostic kit for certain parts of the diagnostic repair, I will then go ahead and be prompted to hook up this EVDiagnostic box to the actual scan tool and the VCM module. So basically, instead of plugging this into the OBD2 connector, if I wanted to go directly into the battery management system, I would plug that in to my EVDiagnostic box. Then I would go ahead and use the 12-volt power adapter, because at this point, remember, I'm unplugging the 12-volt circuit wires going to the battery management system, so I'm going to need to power this, right? So I'd plug those in, the little alligator clips, hook them up to positive and negative, and then this is just an extra safety ground that I would have to hook up. And then my scan tool will go ahead and wirelessly talk to all of this, and this is where I would plug in whatever adapter cable I needed to for this particular car. The scan tool would again tell me the adapter cable to grab. If I had to use one of those universal pinouts like I had to on this Chevy Volt, it would show me the wiring diagram and tell me which pins to insert those into. So this is how I would hook this tool up. Very simple to do on most electric vehicles, because remember, most electric vehicles have the battery pack that's bolted to the undercarriage of the car, just like this one does. So you put it up on a lift. Those 12-volt connectors are usually, you might have to take a bracket or two off, but they're usually very easily accessible. Now on a hybrid, so say like a Toyota Prius or that Kia battery that we used as a demonstration earlier, those are usually inside the car. Well, they're not right out in the open. They're going to be covered by all kinds of different types of trim and everything I got to take off. So those are technically the harder ones, in my opinion, to hook up than the ones that are a full electric vehicle or a pretty powerful plug-in hybrid like this Chevy Volt here, because I can do all this from underneath the car. It's a lot quicker, a lot easier. And again, I don't have to have 12 volts on, I don't have to have my high voltage gloves on, because I'm only dealing with the actual 12 volt low voltage circuit when I'm unplugging those connectors. So it's a very safe way to get those types of test results from me. So I'm going to go ahead and I'm just going to take the diagnostic box out of the equation for the time being, and we're going to talk about how do we diagnose different types of complaints. So I'm just going to take and plug the VCM in first and use it in traditional scan tool mode. I'm going to power up this car. And since it's a hybrid, if the 12-volt battery was low, it will start the gasoline engine up, which it happened to do here. Not a big deal. That'll probably shut off at some point. I'm now going to go ahead and power up my Autel scan tool, and I'm going to start sharing the screen here as soon as this powers up, and we're going to interface the car, and we're going to go ahead and talk about some of the diagnostics. Okay, so you'll see on the screen that with an EVDiagnostic box, I have some new different types of logos here. Right away, it automatically detected, I didn't have to push anything, it detected the type of car for me. Normally, this is nothing real new, but this particular part of it's new. Normally, I'd have to go in and select auto detect. I just talked long enough that it auto detected. And then it gives me those same little icons that I can choose from. So I'm just going to X out of that, and I'm going to go to New Energy. Again, it comes up, it tells me the type of car. I'm going to say, okay, I'm okay with this type of car. I'm going to say it's a Chevrolet standalone diagnostics. If you're an Autel user, you know what that's all about. I'm going to let it go ahead and communicate. It read the VIN. I'm going to say OK. It's going to go through. It's going to search for any kind of different accessories that it might have had. It might prompt me to answer a question if it has backup cameras or something, but this one did not. So I'm going to say OK. And now I'm going to pull up the traditional screen that we would normally see. So I can select a specific control unit. I can select hot functions, which was a thing that's very important for us to do, like parking brake retracting, and when you rotate tires on cars. Again, you know if you got to condition a 12-volt battery, you know the kind of stuff that's found in that area. But I'm going to go ahead and I'm going to say control unit. And I'm going to pull up the hybrid powertrain control module, and I have two of them on this particular car. So let me go ahead and say, let me look at control module 1. Now let's see what our options are here. So I'm going to go first into live data, and I have these options that what I would want to possibly diagnose. So since we're talking high voltage here, I'm going to select hybrid EV. And now I start pulling up live data. So some of the things that I'm just going to scroll through this list and kind of call out attentions as we go here. Drive motor and inverter supply circuit voltage says it's about 386 volts. If for some reason this car did not want to go, well, remember, this is, once those contactors close, this is what the voltage is that's getting up to the inverter to go ahead and be able to be pulse width modulated to allow this car to accelerate. So if I didn't see that kind of voltage there, well, if I saw very little volts, that would help to explain why, hey, this car's not moving out of its place here. My hybrid and EV battery pack current, right now it says it's about negative 16 amps or so. It's negative because the gasoline engine's running and it's actually charging, helping charge the high voltage battery pack. If I were to put this in drive and start driving, that amperage would start to go positive. Drive motor current again for the different drive motors. My ignition input accessory, this is a good way to test the actual start switch on the dashboard there. I'm going to keep going down. Maximum hybrid EV battery module temperature, 75.2, and the minimum module temperature is 73.4 degrees. So I said, remember, when we were talking about that battery that was on the little tool card as an example, I said, remember, this is going to be important when we hook to the battery management system, because I do see the battery temperature here going through the OBD2 connector, but it's just giving me a range of one sensor. And in this case, it's telling me the difference between the highest temperature and the lowest temperature reading sensor. I don't get to see, in the example we showed you earlier, I don't get to see all 12 of those, which is very beneficial to help in your diagnostic procedures. Also, coolant temperature sensors, drive motors, axle torque command, all of these we're going to be covering in this series of electric vehicle type of training of what I use these different types of data stream PIDs for. I also can see the contactor history. Is it open? Is it closed? Whatever the case happens to be. I'm going to go back here and I'm going to go ahead and say, I'm going to escape again. Let's go ahead and select active test and special functions. In active test, I have the ability to bidirectionally control and test some of the different circuits here. Let me go to special functions, and I've got transmission adaptive torque reset. But remember, I had two high voltage control modules on here. So if I select hybrid powertrain control module number 2, and I select special functions, I will have a different set of special functions, right? Hybrid EV battery pack capacity learn, hybrid EV battery pack charging adaptive learn reset, hybrid EV battery pack data reset, hybrid EV battery contactor open reasons reset. So I have the ability to reset a lot of these different areas on the vehicle. We're going to talk about battery state of charge and state of health here. I'm going to go to active test now, and I have the ability to test different parts of the high voltage circuit. So here I've got high voltage EV battery pack active isolation test. Remember, I said before, in order to test that in the past, I would need to use a milliohmmeter and I'd have to take the cover off the battery pack. I have a bidirectional test built into this tool for me to be able to give me an overall grade if there's any kind of leakage inside this battery pack. I also can control the high voltage battery contactors, disable them. On this particular case, I'd rather pull out the high voltage disconnect, test the cooling system pump for the high voltage battery. I have a lot of different weapons in my arsenal to help me diagnose this particular vehicle. I'm going to go to live data here. I'm going to go to data display. Now I have a choice. What type of data do I want to see? So I got battery charger control module. I also have all my high voltage contactors information. I also have the temperature information that's available. They're talking about the temperature of the cooling system in this particular case on this particular car that's cooling the high voltage battery pack. Let me go in and select battery charger control module, or charging module, I'm sorry. So here, right away I have battery charger input is 0 volts and 0 amps. So what I'm going to do, let's say the complaint is I plug my car in all night long and I'm not getting any kind of charge. So I'm going to go over to the charger and I'm going to take the cable back at the car, and this is a 1772 style connector, level 2 only on this particular hybrid. As soon as I opened up the door, little green light comes on. I'm going to plug the charger in. Remember, there's the 3 terminals. The 3 bigger terminals are the ones that are supplying voltage to the vehicle. These 2 small ones are the proximity and control pilot. So I'm going to plug this in. Now, right away, the car dinged. It's not charging yet because I don't have the charger turned on. I didn't set it up that way. So the light's not coming on the dash saying it's charging. But just that dinging alone, so your ear alone, helps you diagnose the proximity circuit that we talked about. It recognized something got plugged in. I can also see that on my scan tool now that proximity circuit actually has changed. Now I'm going to go ahead and I'm going to just hook up my phone so that you can see what I'm doing with my charger. And I'm going to open up the Autel Charge app. And it defaults into allowing us to only see a map at first. So we don't care. There's a lot of stuff that our app can do, but I'm going to hit the charge button and I'm going to say start. Now it counts up. We're going to hear some contactors close on our charger, and we're also going to hear the contactors close on the car. And as it starts to actually deliver the charge on the vehicle, we'll be able to see scan tool data that will support it. For whatever reason, probably because I've got a long HDMI cable hooked up to this thing right now, it's saying my charge is suspended. Now, this is a great thing. I'm glad this actually happened live on camera. It's suspended because the car is running right now, right? So I'm just going to put my phone down here. It won't allow it to charge. That's a safety that's built in. It's a safety that's built in because if the thing is plugged into a charger and you try to start up the car and you drive away with the cord still plugged in. But as soon as I went ahead and shut the car off, the app actually told that charger to turn on. The little contactors closed in both the charger as well as the actual vehicle. And my app is telling me that the vehicle is accepting a charge at this point. There's diagnostics I can do with the app, but realistically, I just wanted to show you real quick. I could set this app up so that it would automatically start a charge if I wanted to. Notice that the green light is now flashing here, plus the green light on the dashboard is flashing as well, telling me that it's delivering current. So, coming back to the scan tool, look at the top lines of the PIDs there. Our battery charger input is now 242 volts, right? The charger is hooked up to a 220 circuit. It's telling me that its charger input is also 15.8 amps. I can scroll down here. It's telling me that it's a battery charger is a 240 AC voltage. The value is yes there. It's telling me that the battery charging system has a passing rate of OK, which means the communication between the car and the charger is saying, I do see you giving me voltage. I'm not accepting all of it. We'll see that a little bit later on. I'm not accepting all of it, but I am accepting some of it. So there is a communication line open there. My battery charger power input available is 3.87 kilowatts, right? Let's talk about that. Our residential charger can put out up to 12 kilowatts of power. However, remember, the car is in control. Now, 3.87 is very small. So even though I have a higher power output of that charger, the car is only going to accept what it can accept. It's always in control. This alone, just what we've talked about so far, goes ahead, and there was a tool that was made that was an EVSE tester. And before Autel came out with this tool, the new scan tool, I would promote buying one of these to help diagnose if the car's got a lack of charging complaint. Is the problem with the charger or is it with the actual car? So you would use this tool to test the charger. So you'd plug the charging cord into this tool. I don't need to do that anymore with this particular scan tool that we have out now. I can use that to see, well, is the voltage actually going to the actual vehicle? I can pull this information up on my scan tool screen here. I also, if I keep scrolling down here, you'll see that I have the proximity detection circuit there. Remember, that is the voltage that was present to say that something got plugged into that orifice, the charging orifice here. I also have a control pilot as I keep scrolling down the screen here. Control pilot duty cycle, control pilot voltage, control pilot period. So if I were to plug and unplug the charger, all those values would change. But I would expect to see with the charger hooked up that all of that is working properly. I can use this to help me diagnose the type of complaint of lack of charging in this particular example. So this particular car is going to take a little while to charge up, but it's going to be about 10 times faster with a level 2 charger as opposed to a level 1 charger, because a level 1 charger puts out about 1.5 kilowatts, right? This has the ability to go ahead and put out up to 12 kilowatts. Now in this particular case, it's limiting it to about 4 kilowatts. So in this example, it'll be about 4 times faster than the level 1 charger. This battery in this particular car is about 50% charged right now from looking at it. I could pull this data stream up and confirm that, the exact percentage of charge it actually happens to be. But here's how I would start to use some of these different types of PIDs here. Now, another thing that I kind of want to show you, and we're running out of time here and I want to leave time for questions. I'm not going to crawl underneath the car, and I'm not going to hook up the EVDiag box because I already took the screenshots of when the battery was replaced the first time. So you already saw the type of screenshots you'd see, but let me go ahead and just back out of here. Let's go escape, 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 hit escape again. I'm going to end this current diagnostic session. I'm good with all of this. All right, I'm going to go back home at this point. The other icon next to new energy says battery pack test. So when I pull up battery pack test, again, tell it a little bit of information here. General Motors, it pulls up a couple little warning screens for us, right? So it's going to tell us stuff like, hey, make sure you have a generalized understanding of high voltage before you start going into doing anything with the high voltage battery pack. I'm going to say that I read all that and I'm okay. I read all these warning and disclaimers as well. I'm going to say accept just to save time. Then it tells me some of the safety precautions here. I'm going to say I'm good with safety precautions. I'm going to say okay. Then I'm going to select Chevrolet, North America, and it's a Volt, and it's a 2017. I'm going to let it do its little thing here when I select OK. And it's going to load data. Here is the screen of what I was referring to of how I would plug in to the high voltage battery. So at this screenshot right here, it's going to allow me to, it's going to identify the cables I got to grab. It's going to show me the connector that I'm unplugging underneath this particular vehicle, and I'm going to be just sliding these terminals in to where it tells me to slide in. Now, one of the coolest features that this tool has the ability to do, remember I said that every battery over time, the internal resistance will start to fail, right? It starts to get higher, which then means the car cannot accept a full charge. So, with that being said, it also decreases the range, and because it's always trying to charge, the battery starts to fail sooner than what it needed to. I have the ability to recalibrate. In fact, most manufacturers recommend doing this as a standard procedure about every 3 to 6 months on a high voltage battery. I can recalibrate this data health. So what am I actually doing? It's taking a new reading, remember a small little milliamperage reading, it's taking a new reading and it's saying the electrolyte inside the individual cells is no longer at wherever it was when the vehicle's battery was brand new, it's now lower. And when I recalibrate that, I can now also recalibrate the state of charge so that now it knows that, hey, to fully charge this battery, I'm going to not base the fully charged battery off of a picture perfect battery cell when it was brand new. I'm now got a new baseline of the battery state of health. So now once that's recalibrated, every time I charge a vehicle, I'm going to be able to fully charge those cells based off of that new baseline. So this is perfect for those customers that come to you and they say, hey, I used to have 53 miles of range when I started first using this car and charging it. Now it's dropped down to 42 miles of range. Does that mean my battery pack's on its way out? Well, technically yes, but you can go ahead and you can recalibrate this and give them the range back, right? So you have a service option available for you that I never had and never still have with any other type of scan tool out there. That is a huge thing for us independent repair shops because, or any professional technician, because as you know, the exception of this hybrid here, when a car no longer has an internal combustion engine, we only have about 21 moving parts in the driveline. So with that being said, we're losing a lot of service intervals like timing belts and oil changes and all that stuff. So we need some way to make up for it. So stuff like we have multiple cooling systems on cars. So there's multiple cooling system flushes. There's different filters. There's a lot of stuff that makes up for some of the stuff, the service procedures that we lost. But this is something that's key. You will go ahead and prolong the life of that high voltage battery pack by being able to just recalibrate it. Now, as always, we never really have enough time in these classes, and I'm going to go ahead and open it up for questions. I'm going to read the questions, but while I walk over to the computer and read it, I'm going to share the computer screen one more time. And I just want to bring everyone's attention to this. If you happen to be going to the upcoming Apex show in Las Vegas, make sure you stop by the Autel booth. We've got some great chances for you to go ahead and get giveaways. The grand prize being an Autel EV diagnostic kit plus a charger. So that is huge. Those are the two main components that we used in tonight's class. And I could literally talk for another 3 hours about different stuff that we can do with this scan tool on just battery management systems. But again, we kind of lost some of our time that we have here because it's only an hour and a half long. So looking over some of the questions that people have asked, I'm going to kind of pick and choose which ones that I can answer the quickest here, since I want to respect everybody's time and I don't want the seminar to run longer than it has to be. Basically it says, is there a PDF for this presentation? So technically there is. I don't know, I'll leave this up to the powers that be at Autel. There are just under 1,000 of you that signed up for this, which is huge. You know, most of the time when I've done webinars for other companies that I've worked for, you know, we'd get 40 to 60 signups, and out of all those signups, maybe there'd be 12 people that actually watched the live version, the rest of them watched the recorded version. This is huge with 1,000, and it would be kind of difficult to go ahead and send a PDF out to 1,000 different emails here. It says, Mike Motto says it looks like a Chevy Volt. You're 100% correct. It says, will it work with Tesla units? It will work with Tesla units. So the new diagnostic tool will work with that, and it'll work with the battery management system, and it will also work with the OBD2. Tesla does not have the OBD2 connector, but we do sell special diagnostic cables that you can hook up to a Tesla here. You need my email. I have an Ultra just purchased. Can I add the EVDiagnostic box to it? You definitely can add the EVDiagnostic box to your Ultra scan tool. Is the EVDiagnostic kit compatible with the 906? So it's only the 909 scan tool, the 919 scan tool, as well as the Ultra scan tool. So it's not compatible with the other part numbers that we have. Lots of questions about the handouts. You know, again, I'm going to leave it up to Autel if there's some way that they can email people, but I don't know the answer to that question. I'd be more than happy to share the handout with you, but somebody's going to have to try to get in contact with everyone. missed the first 15 minutes, is it going to be recorded? It's definitely going to be recorded. Eventually this will probably end up on Autel's YouTube channel. To get the VIN, you have to plug in the dongle. So that was on the 12-volt battery tester. So that's what that was about. Does the Autel EV diagnostic kit for hybrids too? So yes and no. It's got really good coverage from my experience with electric vehicles. And then if it's a later model hybrid, kind of like this 2017 Chevy Volt, from my experience, it works really well with as well. But if you start going into, 2005, 2006 Priuses and stuff like that, it's hit or miss as to the coverage that you can plug into the battery management system on. But the good news is, those cars are fastly disappearing from our service bays at this point. Lots of questions about, is this going to be recorded? It's definitely going to be, it definitely was recorded. Can the EVDiag box perform an insulation test? So when I was first involved with the creation of this and testing of this EV diagnostic tool, I kind of said to headquarters, we could take this a step further. We don't have an insulation tool right now, kind of like the Fluke 1587 voltmeter that we were using. We could create something like that to have a one-stop shop, so to speak, for any shop that's looking to get into the electric vehicle business. But it can't do a high voltage insulation test. So the scan tool can't do that. It's not capable of putting out that kind of voltage. So you would still need the separate high voltage insulation testing digital voltometer to be able to do that right now. But we can do an isolation test with our scan tool. Remember, there is a difference between the two of them from what we said before here. All right, it says, you have an accent, where are you from? So that's not a real important question, but I'm from Ohio, so I don't know if that helps explain the accent or not. Is the EV diagnostic box good for hybrids and mild hybrids? Definitely. Like I said, it kind of depends on the car. The older the hybrid, the more likely that it's probably not going to do as much for you. But if it's newer than about 2012, from my experience, this is a very impressive tool that we have out here. High voltage battery with the scan tool, is there a list of cars that it's compatible with this tool? So the tool actually does have an owner's manual that comes with it. And a lot of good information can be found in the owner's manual. The owner's manual does not give you a complete list of all the different types of vehicles that the car will interface with. However, what you can do if you get the tool is when you start powering up the tool and going into the different types of cars, if you select the battery test icon, you'll know immediately if there's support for the car that you just punched the VIN number in on, right? So you don't even have to have it hooked up to the car. You can just turn the scan tool on, hit the battery test icon, and manually start punching in the information for the car, and you'll know if it supports that vehicle. Like I said, from my experience, and obviously I haven't hooked this up to every single hybrid out there and every single electric vehicle out there, but I have hooked it up to quite a bit. And from my experience, if the hybrid, so electric vehicles, I haven't found one yet that it doesn't work on. I'm not saying it won't work on one, I'm just saying I've never come across one yet that it doesn't work on. Hybrid vehicles, it depends on the year. So the ones that it had no support for, like I said, were earlier ones, like Generation 2 Prius, it didn't work with. The first generation Chevy Volt, that's like 2011, 2012, it did not work with that. But remember, you still have all the extra features that Autel gives you through the OBD2 connector, through the data link connector, which is a lot of the stuff we just saw. So you still have those features. You can't recalibrate state of health and state of charge through that. You can't see the individual sensors, the thermistors. You can't see some of the stuff when you hook up to the battery management system. But you still have a lot of stuff that other scan tools don't show you. So it's still a worthwhile investment for that alone on those older types of hybrids. All right, so at this point, I'm actually 1 minute over. I just want to close out for saying, you know, I literally could talk for another 3 hours about different components, doing more hands-on tests and stuff. I do have a whole series of these webinars planned for you guys, so each month will be something different. So keep an eye out for your emails that are coming through. These are all going to be electric vehicle related right now, or hybrid related, unless the diagnostic team asks me to do something for, you know, diagnostics or TPMS or some of the other circuits there. But right now, my main boss is on the EV side, so, you know, they're going to keep wanting me to do these. So with that being said, this is the first time that I've done an actual training class like this for Autel. And this was not an easy accomplishment to get everybody to sign off on allowing me to do this. So I'm going to ask for your help here. If you enjoyed tonight's class and you want to see more information like this, contact your distributor or whoever you got to contact and say, keep them coming. We want to see more of these kind of training modules for future references. Right now, we do have them planned throughout the rest of the year, but I'd like to be able to continue to do this for you if you guys find it useful, you know, all throughout next year, and as long as I'm with the company, I'd like to be able to continue to do this. So with that being said, again, I appreciate everybody's time. I hope you guys got some information that you could take back to your shops and have a better understanding of how these systems work, for one, but more importantly also to have an idea of how you can use the information that we discussed tonight and saw some of the diagnostic principles that we used here to help you diagnose these cars that are coming in your shop and help you make more money in the future. So until next time, my name is John, and thank you.